This is Algebra 1, Lesson 20, Volume. We've talked about geometric solids before. It's a geometric figure. It's going to have 3 dimensions. Like this example here, you've seen these in games. You roll the dice and you can see how many moves you're going to make on a game board. So this cube, we know it's a cube. We have a length and a width and a height, right? So it is a geometric solid. We can see that it has 6 faces. You can't see all the faces right now because some are turned away from us, but we have this front and there's a back we can't see. There's a left side we can't see. Here's the right that we can see, right? And then we've got this top, which means there's a bottom under here that we can't see. So there's 6 faces to it of this cube. Okay, so we know what this is. We know what a cube is. What is a cubic unit? Well, a cubic unit would be a cube where all of the measurements are whatever unit you're measuring in. So it could be inches. It would be 1 inch by 1 inch by 1 inch. Okay, or it could be centimeters. It could be meters. It could be really big and be kilometers or miles. Okay, so that's your cubic unit, and it's what you use to measure volume. Okay, so volume is how much space this 3D object takes, or how much space, what you can fill it, how much you can fill it with. So let's look at some examples, some pictures here. Your book gives you these examples. All right, we have learned about area. And this area, it's kind of sideways here, the way they drew it in the book, you can see, but it's supposed to be picturing flat. So imagine this as being like graph paper. You're just viewing it from the side. Okay. All right. So this is our little piece of graph paper that is 2 by 3. It is flat. This is just a flat surface. And so the area of it would be 2 times 3, which is 6, and centimeter times centimeter, which is square centimeters. And you can verify that. You can count. If this whole side is 2 centimeters, right, then that means this is 1 centimeter by 1 centimeter. So this little thing here is 1 square centimeter. And we can see we have 1, 2, 3, 4, 5, 6 of them. So the area of that little piece of graph paper, that flat area, is 6 square centimeters. Volume, though, is you're measuring the cubes. You're trying to see how much space it takes up, okay? So notice here it's as if they took some sugar cubes, and I got you a picture of these sugar cubes here, your book references, and it's basically like a little die, okay? It's a unit, a cubic unit, and they're saying imagine taking those sugar cubes and building on top of this graph paper. So here's a cube. You can see it. I'm going to kind of color it in. We can't see the sides. Here's another one. Here's another one. There's one here. We can't see anything but the top of it right now. And here and here. It would take how many of those cubes to cover that graph paper? Well, it would take 6 of them. We could just count it right then, couldn't we? But it would be 6 cubic centimeters, right? Remember we talked about that exponent. When it's a 2, it's a square, and when it's a 3, it's cubed, okay? And this is why, because we're counting the cubes. Now, if we look at the volume of this figure here, we can see that it's built on this foundation of our graph paper, and we can see that there are 3 layers. Okay, here's a layer of sugar cubes, which is going to have this volume, right? Because it's the same as this. But then we've got another layer on top of it. And then we've got another layer on top of that. Well, how many layers do we have on top? Well, there's a total of 3 going up. 3 layers of these going up. So how do we know what our volume is? Well, it's the volume of this in a single layer, but multiplied by 3. So this one's going to have 18 cubic centimeters. And you could count those. Okay, we know there's going to be 6 in each layer. So this whole layer has 6. This whole layer has 6, and this whole layer has 6, which would give us 18 cubic centimeters. So they go into a couple other terms as well, and then they give you a formula, okay? They talk about right solids. They're reminding you that when these geometric solids meet at right angles, like right here, okay, that you're talking about a right solid, okay? So basically it's not leaning, okay? They're 90-degree angle, 90-degree corners, okay? And then it's also reminding us about the bases, okay? So when it's talking about the base, it's like this top and this bottom that we can't see down here, okay? Those are your bases. And then it reminds us about a right prism. It says if your bases are polygons, then you have a right prism. And we talked about that in another video, but they're just reminding you of those things in this lesson. Now, here we have our formula so that we can move on and figure out the volume of some things. We don't have to have sugar cubes, and we don't have to make all these drawings and count all the layers. We can learn from this that the volume of a right, it's meeting at 90-degree angles, solid, is equal to the area of the base. So here's our formula, the area of the base multiplied by the height. And we saw that here. It's the area of the base, right? And then you multiply that by the height. There's 3 of them. And you can use that even if it's not a rectangular prism or a cube like this. You can use that with other geometric solids.